Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. I don't know why. It's always the wrong settings. Anyway, okay, so probably the last interaction with D-Buy guy. So somebody had posted and said this was dispar, which, nah, no chance. But anyway, he did this experiment over and over again, and it all comes down to, just filming it and being able to measure actual velocities. And that's the difficult part. Without a high-speed camera, it's pretty much a pointless exercise. But anyway, so we went through all that crap. Where the hell is the... Well, anyway. Okay, video. All right, so he posted a comment, one of his comments. Hey, I published the collision animation, 3-to-1 mass ratio. So I wasn't terribly interested in just 3-to-1. I thought you were going to do all of them. Have a look. All I can say is that the 4-to-1 speed ratio you proposed doesn't look very good. Oh, what an impressive statement. He's so scientific. Anyway, so this is what he says doesn't look very good. So this he claims is Newtonian physics. So again, I'll draw it out again. But they're proposing that Newton believed you could make free momentum. That is, you could increase the momentum going in a direction. All right, simply by smashing a light thing into a heavy thing. That you could essentially double the momentum as the extreme case. And that you could just repeat that over and over again and obviously increase by, 4, 5, 6 times the amount of momentum something has. And the momentum is significant. That's what he believed in, was quantity of motion. So again, why would he argue against perpetual motion if there was some way you could generate 6 or 7 times the amount of momentum an object has or creates in the universe? Because clearly that seems, certainly it would be fertilizer for perpetual motion. But anyway, all right, so again, their argument is 100 goes in, 150 keeps going in the direction the thing was going in, and that 50 goes the other way, and there would be 100 and 200 in the extreme case, and they think that's a possibility. So this is the illustration of it. Now, the trick is, no matter what speed the pendulum moves at, it always takes the same time. So, you can't go by timing, because it's the same interval between when both objects swing away from each other and the speed of the one object leaving. All of those timings would be exactly the same in the both cases. And all you're really talking about is a little bit of extra direction in the case where the two things collide. Now, the first thing I noticed was, I guess I could blow this up. I mean, he couldn't even bother getting the scale right. You're just saying, why are you even, why are you bothering me with this crap? Okay, when you can't even get this right. Okay, the 0 is here. He doesn't even have the center of the collision on the 0 mark. I mean, what the fuck? It's halfway through this red object. So he doesn't even have the center centered on his scale. I mean, I shouldn't have to say more than what the fuck. All right, so this is what he claims it is. All right, and that somehow is significantly different from... Yeah, okay, and we'll go look at the real thing. So he's arguing that somehow there's a symmetry. There should be a symmetry in the center of mass when it's a very asymmetrical experience. I mean, all the momentum goes off in one direction in one case, and the momentum is split in the second case. Why would you expect a symmetry in that circumstance? I wouldn't expect a symmetry. So we'll play a little more of that. And then he adds the center of mass again, which is, who cares? What's that have to do with anything? Oh, that's right, nothing. I mean, it's interesting, but I mean, again, it's a very asymmetrical event. Why should I think the center of mass is going to be symmetrical? Yeah, I shouldn't. Is the point. So now we'll look at the video of the real thing. He couldn't even bother doing this. Now, this video, you can see the angle it was taken at, right? You can sort of get the idea that the guy's photographing it from like a 45-degree angle. So, you can see the strings, you can see the V's of the strings. So he didn't do it face on, so the strings are this way. So it's at an angle. So the strings are going like this, you can see that. So instead of filming it straight on, he filmed it from the side of the small object. So its arc is going to be quite distorted because it's moving towards you and away from you instead of moving side to side. So why would he do that? All right, anyway. But, this is, and you can see it's very asymmetrical. So it's this, oh, shit. Well, that was disappointing. So he could have done that ahead of time, too, but he didn't. All right. So yeah, you can watch the top view and then the secondary view. But clearly, it's not a symmetrical event. So there you can see it, But this is such small amount movement, and again, he filmed it from this bizarre angle. You can't quite see it in your video, but this is the strings going up. You can see they're going up at this angle. So clearly it's not being filmed on the center, which, why? Simple enough question. All right, so enough of that. So again, where his animation doesn't, that could have been done better, Gary. Yeah. All right, let's see if we can get a little more of that. Should be able to see that now. Yeah, you can see that. So by simulating it, he say somehow he showed something that was different than that. But you can't really show it any different. It's just about this distance. One of them goes, whatever, 1.5 millimeters further. They go a little further apart for twice the velocity, that one velocity, because it's on an arc. So, it doesn't start costing energy gravitationally. Still, you start going up in the arc. Going flat in the arc doesn't... It's all the same thing for both. And it's not until it's going up that it starts taking away all of its energy. So the difference in the distance will be a tiny amount of difference. So the two things would look pretty much exactly the same. Again, the time would be exactly the same. So it doesn't matter whether the pendulum swings really slowly or it swings really fast. It actually takes the same amount of time. That's, a Galilean thing. All right. So leave us just go to the drawing, I guess. And, well, I guess I'll read his other comment first. All right, because I'm just going to block him now. Yeah, this is just such bullshit. So he says, but physics doesn't predict that an object with higher KE will win the tug of war. So he's saying the thing with the higher energy, and the whole argument between Leibniz and Newton was that, and Huygens, was that mv squared is the quantity conserved in the universe. That's the quantity conserved. So there's no way that can be true, that you can say this crap you said. So you're talking for physics, and your argument is absolutely in complete contradiction to what physicists say. Kinetic energy, in their opinion, is the real energy. It's the stuff that can really do work. They say that when you add the 5 mass to the 10 mass cart, going 10, and it ends up being a 10 mass going 5, their argument is that the kinetic energy is there, that you used a whole bunch of it doing all kinds of movement and breaking things and smashing things and making all kinds of sounds and all this other crap. But they've never proven it. Their argument is that when I have the ballistic pendulum and I shoot the bullet into it, their argument is that, yes, I only collected 0.06 of the momentum, the kinetic energy in the movement of the ballistic pendulum. But they say the 1999.4 okay, of the rest of the kinetic energy is in the ballistic pendulum, but they just never thought to stick a thermometer in there and prove it. They say it's there, so don't pretend they don't think it has to do work. It has to do work. And my argument is you have no examples of it actually doing work. All right, kinetic energy doesn't describe the ability to change the motion of other objects. It's just amazing. The definition of fucking kinetic energy is the motion of an object. That's the very definition. I mean, it's just such a lie. It describes the ability to travel against some resisting force. So he has no citation to this bizarre definition. Nowhere in any physics book or anywhere does it say these words. You're just such a liar. Okay. I don't know how you are not able to learn this after so many times. Because you haven't shown me a single physics professor saying that crap. Not a single person, physicist, any person with any kind of authority saying some sort of nonsense. It describes the ability to travel against some resisting force. Except it doesn't have to be conserved. Yeah, no, they don't say that. Oh, you're such an asshole. All right. So, yeah, you're done here with that crap. You just made that shit up. I mean, you have nothing. Professor Lewin never said any such thing. Nobody ever said any of this crap you just spewed, that kinetic energy doesn't have to be accountable. I mean, Professor Lewin did say, oh, hey, you can, you can you can deal with kinetic energy one way or the other, but you can't finagle momentum. He did say that, but when he said finagle, he didn't mean you can say it doesn't exist and it doesn't have to do work. The 8-pound bowling ball doesn't have to knock down more pins. Show me the physics person that says that, the physics professor, and then I want to hear his explanation. If it doesn't have to do any work, then how are you calling it energy if it can't be found? Again, Richard Feynman made it clear. There's so many blocks of energy and they can't be destroyed. You just have to see where they went. Oh, fucking lying sacks of shit. I just hate people. All right, so let's just go over it one more time. But this is what they're seriously saying you can do in the universe. Okay. And that they say Newton believed this. So you can take a small mass, all right, and collide it with a large mass. And let's say it's a much larger mass, 10 times. So now I'm going to transfer almost twice as much energy. Let's just, for the sake of argument, it's a big enough mass where it still moves, and I'm going to transfer 199% of the energy. So this is going to come in with a certain momentum. We're going to call it 100. And I'm going to put 200 almost, okay, into the object. And I'm still going to get my reflection back, which means if it was a pendulum, I'm just going to get the energy back again. It's going to hit again. And I can just do the same thing all over again. I can put another heavy mass, just have it roll right into place, and it can hit it again, and then it can hit it again, okay, and it can hit it again. And I can end up with 200 here, and then 200 here. So I can do it, say, just if I only did it 3 times. And see, each time it would decline a little. Let's say, for real losses in the world. So I don't have to make this an idealization. I can say, let's say this number is 198, and then the next number is going to be 172, and then 150, whatever, and I could just do it again. And by the time I'm done, I can end up with 600% of the momentum I started with. So I put just 100 in. I pull back the thing and just use 100 momentums, and I end up with 600 going in the direction, okay, of the initial action. And so now I have, 6 times as much energy, motion, momentum, weight, pressure, moving in the direction that I created the imbalance in. And they think that's a realistic prospect. And so they also think the opposite is true, that I could have 600, or let's just use the example of the 3-to-1 ratio pendulum. Okay, so I have 150 momentums, and I have 50 momentums in a car crash. All right, and their argument is when those two cars crash. Now, they're certainly going to concede if they crash inelastically, that is, they bend fenders, that they're going to do 200, okay, momentums worth, the MV of all the little dents and all the crashes and all the pieces flying off. They'll concede that, yeah, it's going to be 200 worth of momentum in the crash. And it's only when they bounce off of each other, okay, where I made them elastic, rubbery, that somehow, just because I made them, I put springs on them, somehow, okay, I'm going to have 200 total momentum in a crash, and only 100 is going to pop out. And that's it, just the 100. So the big mass is going to stop, the mass with the same velocity. So they're both going 50 miles an hour, but this one's 3 times the weight. Okay, and this one's only 1 unit of weight, 1 mass, and it's going 50 miles an hour when they swing apart. And then when they crash, they're going to sit there and produce. So I have a 1 mass going 50 coming in, and I have a 3 mass going 50, okay, coming in. So a truck 3 times the size of the car is now going to hit a car. The car is going 50, the truck's going 50, and somehow miraculously only 100 is going to pop out. So even though there's 200 momentums coming in total, only 100 pops out. And then in a pendulum, I can just keep redoing it until the 100 goes in, it creates 200 again. And then it turns back into 100. And then there's 200. And then there's 100. So that's their theory, that they can create and destroy momentum at will. No problem. They can create a system that goes from having 100 quantity of motion, things moving, and make it 200, and then I can go back to 100, and then I can make it 200. And like I said, I can take the extreme case where they're going to argue I can go from 100 to 300, and then back to 100, and then 300. And he thinks this crappy simulation that isn't even zeroed properly is somehow going to makes a convincing argument, demonstrates the truth. Okay, and he doesn't say, oh, physicists really should do this experiment. Isn't all that challenging, to sit there and just, do the experiment of, filming it with all these people with high-speed cameras, and none of them can, well document exactly how, this creation of extra momentum, actually film it straight on, do it by reasonable rules. Nobody can manage it. Yeah, bullshit. All right, so enough of that. So somebody else did leave a comment talking about relativity and how that can be used to prove the case. And I really don't want to make relativity arguments, because I have the whole subject is polluted by some notion that there's real relativity, like somehow things can be, you can create relative spaces where someplace the speed of light is 10 times faster than it is in other places, and other crap like that. And I don't see any reason to play in that ball field. But appreciate the effort, appreciate somebody else making arguments. Because somebody, says, the truth is, it's kind of, it's just so obnoxious for these people to argue that Newton believed in mv squared when he clearly said twice the force, twice the motion, 3 times the force, 3 times the motion. And on top of that, the idea that Newton wouldn't know that free quantity of motion would be problematic. That a ball bearing bouncing on an anvil is putting more and more with each bounce, it's putting energy into the anvil, and so there's 1,000 times more energy in the anvil than the ball bearing started with. Pretty ridiculous assertion, in my opinion. clearly the ball bearing is reflecting off the anvil. It is not transferring its energy. And as soon as you transfer your energy, that's when you don't have it anymore. If something else has the energy, the motion, you don't have it anymore. If you're in a system, closed system, okay, and the other stuff doesn't have energy and you do, and then in the next version, next frame of the system, something else is moving, then you're moving less. And the more they're moving, the less you're moving. All right. So anyway, I hate people. Just hate them.